Alright, so let's talk about the potential difference in a series circuit. Okay, so just now we talked about the current is the same in a series circuit, right? What about the potential difference? So for example, let's just say I have a EMF of the battery, which is maybe 4 volts. And I have something like a 2 resistor, which is adjacent to each other, right? So how does the potential difference compare? So imagine that we have the same resistor. Okay, so let's just say we have a same resistor, okay, so this case 1, the same resistor of 1 ohm and 1 ohm. So what should be the potential difference across each of the resistor? Okay, so of course, just now we use the current, right, which is 2 ampere. So I can actually use the 2 ampere to determine the potential difference across each of the resistor. So for example, let's just say I have a current of 2 ampere, right, flowing through the first resistor. So of course we know that we have learned R equal to V over I. So your R is 1. Of course your current that is flowing through the first resistor is 2 ampere. So let's put down 2 ampere. Okay, so you can see that your potential difference across the first resistor is 2 volts. So this is 2 volts. Okay, so now we go on to the second resistor. So second resistor, we also have a current of 2 ampere flowing through. So 2 times 1 is also 2 volts. So that is the meaning of potential difference in a series circuit. So you can see for the example of a similar resistor or the same resistor, right, the potential difference will be equalized. So it means that 2 and 2 is the same. But they add up must give you a total volts of 4 volts. You cannot have, like let's just say you cannot use this add with this, right? You'll get more, cannot be, because the maximum you can go is actually the EMF of your battery, 4 volts. Okay, so what about case number 2? Where case number 2, let's just say I have different resistor. So let me just erase this first. Okay, so for example, let's just say I have same thing. I have a battery EMF of 4 volts, and my first resistor is 1 ohm. My second resistor will be 2 ohm. So let's put down 2 ohm here. Okay, so let's use the R equal to V over I to determine what is the total current that's flowing through your series circuit. So for the current, right, so of course the total resistance is 3. 2 plus 1 is 3, right? So R equal to V over I. So R is equal to 2 plus 1, 3. Your V is the total EMF or the voltage of the battery, which is 4 volts. So when you use 4 divided by 3, right, your current that is flowing through is about 1.33 ampere. Okay, so try not to put 4 ampere, because in physics wise, right, put in terms of decimal, 3 SF, right? Okay, so we know that the total current now is 1.33 ampere. So 1.33 ampere that's going to flow through the first resistor. So 1.33, of course, you simply just use R equal to V over I. So 1.33 times 1 will give you a voltage of 1.33 volts. Okay, what about the second one? The second will be 2 ohms. So 2 ohms, of course, you just use R equal to V over I. So R is, okay, so I'm just focusing your attention on the second resistance, which is 2 ohms. So your current is flowing through your second resistor is 1.33 ampere. So 1.33 is 1.33 here. So 1.33 times 2 will be 2.66 or 2.67. So 2.67 volts. So you can see for this thing, right, 1.33 plus 2.67 will give you back the 4 volts. Yeah. So if let's just say your resistance has a different resistance value, right, then the voltage will be different. Of course, a rule of thumb, you can think of it as R increase means that your voltage increase. Because why? Because R equal to V over I. Your R increase, right? So assuming that the current is the same, constant, the V must also increase. Okay, so that is the potential difference in your series circuit. So how do we measure your potential difference? Of course, we must use your voltmeter. So the orientation of your voltmeter, right, is a bit different from your orientation of your ammeter. So for example, you can see that the voltmeter is connected in this parallel fashion. So this is how we measure your voltage. Okay, so V1, V2 measure the potential difference, because remember, potential difference refers to anything but the battery. But for V3 right here, this measures your EMF. Because this voltmeter is connected to the battery, right? So that's why it's called EMF. Okay, so just remember, for voltmeter wise, theoretically speaking, the resistance of voltmeter is very very high. Or theoretically speaking is infinite. Because why must it be infinite? Because when the current flows, right, you must make sure that the current doesn't flow through the voltmeter. So that's why the resistance must be infinite. So the metal or the things that made the voltmeter, the inside of the voltmeter must have very very high resistance, right? So that is the meaning of your potential difference.